Good morning to you. We're going to talk about how to solve simple rational equations, which is actually a 3.0 target for this unit. So this is a major goal for us. When we are solving rational equations, we're going to approach this kind of like we did for adding and subtracting. So you're going to factor all denominators and identify the restrictions on the domain and find the LCM. The difference is after that, we don't multiply by missing pieces. We're going to multiply the whole LCM by every fraction. So let's kind of see how that goes. And then afterwards, you're going to simplify. It'll get rid of fractions for you, and then you can solve the remaining equation. Okay. So first step, factor, if you need to. We don't need to here. And then find the restrictions on the domain. So if I set my denominator equal to 0 and solve, I get -2. So my restriction is that k cannot be -2. Okay, for my LCM, my common denominator, I always start with the bottom of the first fraction and then compare it to the rest. So notice this 3 has a 1 on the bottom. Technically not there, so we don't need to worry about it. And then k plus 2, which we already have. So my LCM is just the k plus 2. This is where your steps change compared to what you did for adding and subtracting. I'm going to take that LCM and multiply it by every part of this problem. So I'm going to do k plus 2 times every single part. What this does is it gets rid of fractions for me. So I actually don't even have to worry about fractions, and we just have a basic equation to solve. So my denominators cancel for my first fraction here. The second one, it doesn't cancel because this is just a 1 here, so I don't really need to worry about it. So I still have a 3 and then k plus 2 in parentheses. And then the third fraction, my k plus 2's cancel, so I'm left with the plus 1 there. Okay? Now, by using the trick, fractions are gone. All you need to do is make sure you can solve a basic equation from Algebra 1. So we're going to distribute the 3. So we get 3k plus 6. We're going to combine like terms. And then solve from there. So we get k equals 0. Okay, and you're good. Next one. Find your restrictions. Set the denominators equal to 0. Notice they're all with an r squared. So when I solve those, I actually get that r can't be 0. So my restriction is r can't be 0. Then for my LCM, I always start with that first fraction, so 4r squared. Now notice this has an r squared there, which is already in my LCM, so I don't need to worry about it. 2 goes into 4, so I'm good there. And r is included here. Even though it's an r squared, we still have an r there. Okay, so I'm going to multiply each fraction by 4r squared. Just the numerator, though. And then I'm going to simplify whatever I can simplify. So notice 4r squared and 4r squared cancel, so I'm left with 3. For the second fraction, r squared and r squared cancel, so I really have 1 times 4, which is 4. And then for this last one, r cancels with one of these r's, so I'm still left with an r there. And 2 goes into 4 2 times. So I have 1 times 2r, which is 2r. We're going to subtract 4 from both sides. -1 equals 2r, and then solve by dividing. It is very common to get fractions for answers here, so don't panic when that happens. We get r equals -1/2. Let's do another one. These we have to factor first. So I'm going to factor a GCF out. So I have x times x minus 8 and x times x minus 8. Okay, and then I'm going to find my restrictions. So I'm going to do x equals 0 and x minus 8 equals 0. So my restrictions are that x cannot be 0 or 8. Okay, so our restrictions are 0 and 8. We are going to find an LCM. So if I start with my first fraction, I have an x. Okay. Second fraction, I have an x, which is already there, and an x minus 8, so I'm going to add an x minus 8. And then the third fraction, I have an x and an x minus 8, which I already have in there. So I'm going to use my LCM and multiply by each numerator. And then simplify whatever I can simplify. So we're going to go ahead and cancel. in the first fraction are x's. So 1 times x minus 8 is just x minus 8. And in the second fraction, I'm going to cancel the whole thing. So I'm left with a 1. And then in the third fraction, I'm going to cancel the whole thing, so I'm left with 5. Solve this equation and you're good. So negative 8 and 1 is negative 7. Add 7 to both sides to get 12. Okay, one more, and then you'll try some on your own. Okay, factoring everything we can, so I'm going to take out a GCF here, so I'm left with 16 times a plus 1. Can't factor the second one. Third one, I'm going to factor 16a, so I'm left with a plus 1. So my restrictions here are that a cannot be 0 or negative 1. Okay, so you're going to do 16a equals 0, a plus 1 equals 0, 16 equals 0, which we don't need to worry about. And that's how I got those. Okay, and then for my LCM, starting with the first fraction, I have this, 16a plus 1. Second fraction, I have a 2. 2 goes into 16, so I'm good, but I also have an a, so I'm going to put an a in there. And then the third fraction now, notice it matches, so I have everything I need. So I'm going to multiply the numerator of each fraction by 16a times a plus 1. And simplify. So 16 cancels, a plus 1 cancels, so I'm left with 1a. For this one, 2 goes into 16 8 times, and a cancels, so I'm left with 8 and a plus 1. And then for the last one, the whole thing cancels, so I'm left with minus a minus 8. Okay, left those parentheses there for a reason, especially because of that minus sign there. So now we're going to distribute and distribute. Watch that negative sign. And then combine like terms. So 8a minus a is 7a, 8 plus 8 is 16. Move my a's over to the same side, so I get negative 6a equals 16. And then divide by negative 6 to get a equals negative, if I reduce that, 8/3. Okay, go ahead and hit pause and try your guided practice problems. I think there's just one there. Yep, just try that one. And then when you're ready, go ahead and play to check it. Here you go. First, set the bottom equal to 0, so x equals 0 is essentially what you're looking at. X squared equals 0, 7x squared equals 0. I'll give you the same thing. So my restriction is that x cannot be 0. My LCM, if I start with my x squared, I need to add a 7 for this one, and then I'm good for that one. So I use 7x squared for each of those and cancel them. So my x squareds cancel to give me a 7. My 7x squareds cancel to give me 1. And my x's canceled to give me a 7x left over. And then I just solve from there. We will spend another day practicing this when I am back in class. So do your best and have a great day.